All right, we are in chapter 6. We're dealing with equations here. And in 6.1 and 6.2 and 6.3 we deal with trigonometric equations here. So now we're halfway through. So 6.1 were the basic ones, just getting us used to what it is to solve an equation, trig equation. 6.2 now deals with a little bit more robust way of doing it here, with some methods here that we need to do it. And then 6.3 is going to be the involving multiple angles here. So let's begin here. So maybe we'll just do it this way here. So the first three deal with the methods of doing it. So these three deals with methods. So one way is to use some identities. Use an identity to solve the trig equation. In fact, exercises we're going to see is exercise 1 and 2 deal with that. The other method of doing it is to clear denominators. What it means to clear denominators as far as trig functions are concerned. And we are going to deal with exercises 3 and 4 to help us with that. And then the third method is squaring both sides. So there it is. Third method is squaring both sides. And I've set up 5 and 6 to do that. And then we have a last one here, graphing calculator to approximate an answer or verify answers. We'll do more like verify answers, and that'll be exercise 7. So there's a breakup of the way we're going to do this. So let's jam with it. So solve 2 sine theta plus sine 2 theta is equal to 0. And so first things first, what you want to notice is, are you in radians or degrees? And what I'll do is I'll switch these out, and then just for you to practice both of them here. So you got to think to yourself, am I in radians or degrees? That's the way I'm going to look at my unit circle to find the answers for them. Alright, also notice that theta does equal 0, because 0 degrees equal or less than theta. But then theta does not equal 360, so don't go around the whole entire unit circle, and we'll sort of see that in this problem as well. Alright, so it's anything less than 360. So let's go for it. First example, there it is, 2 sine theta plus sine 2 theta equals 0. I need to solve this. So I can't solve it yet because of this is sine theta, that's sine 2 theta. That's not going to help me solve things. I can't put those together into one trig function. But we do have a little identity off to the side. Sine 2 theta, it's called the double angle formula for sine. It's 2 sine theta cosine theta. That's the identity. And if you need to kind of look at it here, it's on the front cover of your textbook. The right hand side of the front cover of the textbook has all those identities. So really use that as you do this problem, or these problems where you have to substitute identities. Alright, as I look at that, what I'm going to do, I'm going to substitute exactly that. So 2 sine theta comes down. And that's going to be changed into 2 sine theta cosine theta is equal to 0. Perfect. Okay, from there, now we're talking about solving this. So I notice I have 2 terms. I also notice I have things inside them that are the same. So right here and right here. I think I can factor out a 2. I can also factor out a sine theta out of this. And so we practiced factoring in 6.1. So if you forgot about it, go back to 6.1. In fact, these are very, very sequential sections here. You got to know 6.1 very well in order to get to 6.2. 6.2 has to be known in order to get to 6.3. So kind of practice that. If you're kind of not sure, go back to the previous section. Alright, with that, if I factor out the whole entire term, I'm still left with 1. Let's see, I factor out the 2. I factor the sine theta on my second term, so I'm still left with cosine theta. Alright, from 6.1, I know if I have 2 things that are multiplying together, 2 products or factors, I could split them apart into 2 different pieces and then solve them individually. So there's that. And on the left side, let's keep on going here. Oh, that's a little too far. Divide this by 2, divide this by 2 to get sine theta by itself. So sine theta is still equal to 0. So notice right here. So anywhere from 0 degrees to just shy of 360 degrees. When does sine theta give me a 0? So look on your chart if you need to, but it's going to happen here, and it's going to happen here. So from this side here, I say theta is equal to, let me make theta look a little better there. Okay, 0 degrees, 180 degrees, but we don't include 360 degrees, right? So we got this one, but then we move on to get this one. We don't include the full term going over here because we don't need to include the 360. We're just stopping just shy of it. Done. Okay, let's do the other side. So I'm just going to subtract that, and the question is, when does cosine theta give me a -1? I'll let you guys try it first. Go ahead, look at your unit circle if you need to. Cosine theta gives me a -1 at, hey, that's interesting, it's at 180 degrees, just like right there. So I have two answers that are the same, and that's okay. That's no problem. So from this one I get theta is equal to 180 degrees. Okay, at the end though, you want to kind of just state your final answer. The final answer is 0 degrees. We're just going to include both answers here. 0 degrees and 180 degrees. There it is. That is the answer to the first problem. Alright, are we good? Okay, second problem. Very similar. You want to be able just to change or use an identity in order to change up the problem so then you can solve it. So this one's our next one. Hey, look at that double angle formula for cosine. Looks like that's what we're solving here. Alright, so first things first, we are still in degree mode. That's nice. We're going to go from 0 to just shy of 360, so we're still in degrees. Our variable has changed. It's now an x instead of a theta. That's okay. We can still work with it here. Okay, so for cosine, here's a little problem for cosine. Is that, remember, cosine has 3 different versions for double angle formulas, right? There's your first form, second form, and third form. Since we're trying to solve these trig functions here, here's what I want you to pick. You want to pick the one that has the extra or it has the other trig function inside the equation. So that little underlined cosine of x, because that's cosine of x, I'm going to use this formula, the second form. If this cosine was a sine theta, then definitely I would use the third form, because I want the trig function to be exactly the same. That's the whole point here, because I can't solve a cosine and a sine easily. So because the underlying trig function is cosine, I'm using this form right here, and since our variable is not a, it's x, so this becomes 2 cosine squared x minus 1, that's what this part becomes, minus cosine of x equals 2. Okay, now let's keep on working through it here. So I can drop the parentheses completely. And I notice I have a cosine squared, and then I also have cosine. So I have kind of like a squared term of itself. So in this case, in my mind, think back to algebra. And algebra kind of makes me think of kind of like stuff like this. You know, 3 equals 0. Notice it's going to be like a trinomial. That's exactly how I want to put it. I want to put it kind of more like in a trinomial form. So that cosine squared stays exactly where I want it. This little minus cosine is going to scoot in the middle. And that little minus 1 is going to scoot to the end. So from algebra, we know that whenever we have a trinomial, we're going to have to factor this. So I'm going to scoot this little minus 2 over as well. What is that, minus 3 this time, right? And we're going to have to factor this down. So if you're still having a little problem, like factoring trig functions, how in the world do you even do that? What you want to do is you want to kind of think to yourself back to algebra. How would you solve something like this? Notice I just took the cosine out of it. So if you're having difficulty with that one, try this one from algebra. Like, you know what, I think I remember. I can factor this down into, only way you can get a 2x squared is a 2x times x. Let's see, and then the only way to get a negative 3 to factor it down, and I want a minus 1 in the middle. So I think what I do is I put a, let's see, I think it's a 1 here, a 3 there with a minus. That would be the plus. So think about how you, this is called the guess and check method of factoring, right? So notice we get our 2x squared from 2x times x. We get a negative 3 from negative 3 times positive 1. And then all we got to do is check our outside terms. That's going to be a 2x. And inside term, negative 3x. Do those two add up to a negative 1x? They do. Okay. That's the same concept that we have over here. So how do you get a 2 cosine x squared, or cosine squared x? It has to be a 2 cosine x times cosine x. How do you get a negative 3? So then in the middle you get a negative 1. So just by what we just did from algebra, the only way to do that is by this. So there's my negative 1 times positive 1 gets me a negative 3. And then all I got to do is I check my middles. So outside, 2 cosine x times 1 gives you cosine x. Negative 3 times cosine x gives you negative 3 cosine x. And if you add those together, will you get a negative x or negative cosine x? Yes, you do. Absolutely. We know we factor this correctly. You know what? I don't even need to erase that. I can keep that there. And then we have to split them up, right? So this part here, I'm running out of room here, so I'm going to bring it up to here. So 2 cosine x minus 3 gives you 0. Or the other split is cosine x plus 1 gives you 0. So as you solve this, a question sometimes comes up. Mr. H, could you solve this? Or Mr. G, can you solve this by quadratic formula? Absolutely. You can solve this by the quadratic formula. It'll solve the same way, but we're going to practice factoring here. Alright, so here it is. When does cosine of x gives you 3/2 along the unit circle? And answer is nowhere, because cosine of x can't be higher than 1. The highest it will go is 1, so no answer for that one. Phew, that's cool. The next part, solving this one here. So we're going to subtract 1 from both sides. Cosine of x is equal to negative when along the unit circle does cosine x gives you a negative 1? And in fact, I think we did that on the previous number. It's right here, right? It's right there. Alright, so the other answer, the only answer here is, let's see, x is my variable, so x equals 180 degrees. There it is. There's my answer for number 2, for example 2. Okay, good. Hopefully you got it. This is solving trig functions by substituting the identities or replacing things with identities. Example 3 introduces a little bit different concept. It's called clearing the denominator. So this is a little bit different. So let's go for it here. So examples 3 and 4. So we are still going to use our identities, but kind of think back to what we have as an identity. Cosecant theta. Cosecant theta is equal to what? It is equal to 1 minus sine theta. Okay, that's what we're going to play with right there. Okay, still we are in degree mode. That's cool. Let you write it out so you guys can write it out real quick. Alright, and with that, let's go for it here. So if I substitute 1 over sine theta into this, it's going to become square root of 2 times 1 over sine theta is equal to 2. And maybe even make it even more easy to read. We're just going to multiply the top there. Okay, so how do you clear denominators? Here it is. Do you guys remember in algebra is the fact that you cannot have zeros in your denominator. So this sine theta, there are some answers that are going to give you a 0 here. Now it doesn't always work out, but you got to kind of think about, okay, sine theta, I remember sine theta. Sine theta is a curve like this. Right? Or if you think about it, the unit circle. And so at times, sine theta does give you 0. So those particular points, we are not able, no, we're not going to use those anymore, so you can't use that. All right, there was a helicopter passing by, so I paused it. So if you get answers where sine theta is equal to 0, we're going to discard those. So off to the side, what we do is just to remind ourselves, we just do this. So sine theta cannot equal 0. We're just going to remind ourselves if we get that as our answer somehow later, we're going to discard those answers. We can't use them. Makes this undefined. Alright, let me change pen color so see what we're doing here. So now what we're going to do is we're just going to multiply both sides by sine theta. This is called clearing the denominator right there. We have cleared our denominator. We made sure that we understand that. We're not going to use any one of those kind of answers. And now we can keep on going solving the problem. Square root of 2 on one side, now it's 2 sine theta on the other. Divide both sides by 2, and I'm looking for this. I'm looking for square root of 2 divided by 2 is equal to sine theta. So on your unit circle chart, going from 0 to 300, or just shy of 360 degrees, tell me when do you get a square root of 2 over 2 for sine. And I think you should get it in quadrant 1. And then the other part is in quadrant 2. So I think if you did it correctly, you should get 45 degrees and 135 degrees. There it is. So how about theta equals 45 degrees, 135 degrees. And there's our two answers. We are done. So do you guys remember back in 6.1? Remember back in 6.1? Sometimes it'd say, give me all the answers. Give me all degree measurements. Give me all radian measurements. That's good for us to begin with, but usually when we're solving trig functions, you will be defined to one revolution. So either 0 to 360 or 0 to 2 pi. That's most usually what happens. Alright, so hopefully that kind of helps out here. Example 3, let's go with example 4. Again, very similar. We're going to have to clear the denominator. Alright, let's go with it here. So, okay. I'll let you guys write, give you guys a few seconds to write out the problem itself, so you don't have to pause the video here. Alright, and first thing I notice here is now we are in radian mode. So when we get our answers, they'll be in radians. That's what that signifies there. Alright, and I think we're going to go with it. In fact, we're substituting the same exact thing that we did before. So cosecant, I see the little cosecant theta over here. And I'm going to substitute 1 over sine theta for that. And if you want to go ahead of me, go. See if you can be a little bit ahead of me here. So the left side is still 2 sine theta minus 1. Cosecant is 1 over sine theta. And for us to clear our denominator, what we're going to do okay, that was weird. we are going to write on the side somewhere, if we ever get answers of sine theta is equal to 0, we're going to discard them. That's not possible for us to have that. And now let's clear our denominator. Here it is. We're going to multiply both sides by sine theta. And the reason why we're doing that is so that we can cancel this right here. That's the whole point right there. Alright, what are we left with here? Actually, we have a distributive property here. We're going to multiply this in. This becomes 2 sine squared theta minus, we're going to multiply this guy in. That becomes sine theta times 1 makes sine theta. On the other side, everything canceled, huh? So I'm just left with a 1. Okay, and I see this now. I see the fact I have a perfect square of the same function. So I'm going to have to set it equal to 0 and start factoring, just like we did in algebra. So think back to something. Think back to what would you do here in algebra if you had a 2x squared minus x equals 1. You would subtract 1 from both sides, right? Set it equal to 0, right? And then start factoring down. So that's exactly what we're going to do here. So let's try it. So first things first, before we start factoring, we have to set things equal to 0. Or else the factoring process does not work. There, set it equal to 0, and then I'm going to try to factor this down. Let's see if we can factor this down together. This is the guess and check method again. So I need two numbers multiplied to give me 2 sine squared theta. That's the only way to do it, is 2 sine theta times another sine theta. Okay, got that done. So then I need to multiply two numbers on the back end to give me a negative 1. And so that in the middle, I'm going to give myself a negative sine theta. That's the whole point here. And so if I do this, let's say if I do this, I put a plus 1, minus 1 like this. This is why it's called guess and check. Because what we do is we guess it's negative 1 times a positive 1. And we put them in, then we start checking. So 2 sine theta times 1 makes 2 sine theta. A negative times sine theta gives me a negative sine theta. If you add these together, do you get yourself a negative sine theta in the middle? No, you get yourself a positive 1. Okay, so if you see that happening where it's just a sine problem, so sine 2 theta minus sine theta gets me a positive sine. I want a negative sine. If it's just a sine issue, what we do is we just switch the signs. That's all. That'll get us what we want. So just that right there. And so if you wanted to, you can even check it here. Let's see, multiply this together. You get yourself negative 2 sine theta. Multiply this together, gets you a positive sine theta. And when you add this one and this one together, do you get negative sine theta in the middle? Yes, you do. Okay, perfect. Okay, I'm still running out of room. So I'm going to, I'm going to go into the next slide with it, but split these two off, set each of them equal to 0, and let's solve each of those. Alright, go for it, see if you can get ahead of me. So split each of those off, 2 sine theta plus 1 equals 0, or sine theta minus 1 equals 0. Split them off and solve. Alright. I'm going to try this as well. So plus 1 equals 0. I just kind of ran out of the room on the previous slide. I'm going to go with sine theta minus 1 equals 0. Let's solve each of those. And what are we in, degrees or radians again? Okay, radians. We're in radians. And so we're going to solve in terms of radians. Let's go for it here. So subtract 1, subtract 1. 2 sine theta is equal to a negative 1. Divide by 2, divide by 2. Alright, sine theta is equal to negative 1/2. Where along the unit circle, do we get a negative 1/2 for sine? Alright, as you're looking here, I think we get a negative 1/2 at 7 pi over 6. And then we also get another one at, it's kind of like this right here. We get the other one at 11 pi over 6. Perfect. Let's leave that alone. We'll put it all together in just a bit. Now let's go on to the next one. Let's add 1, add 1. And I got myself sine theta is equal to 1. When does that happen? When does sine theta give me a 1 along the unit circle? That's right at pi over 6, or sorry, pi over 2. Okay, so just by kind of having those drawings, did we get sine theta equals 0 anytime? No, so there's no one that we need to discard. So I think we can accept all of them. Let's get a list going here. So theta equals, doesn't matter what order you put them in, as long as you have all three of them in there. And so 7 pi over 6, 11 pi over 6, and pi over 2. I think if you see the back of the book, they're always going to go from like the smallest to the largest. That's the way it's normally given. But it doesn't matter. As long as you have all three of those answers, you did good. Alright, we come to the third method of solving these. So let's talk about something from algebra. Let's talk about extraneous. Let's see if my pen writes. There it is. Extraneous. Okay, let me write it on the white part here. Extraneous solutions. That's what we call it in algebra. Do you guys remember hearing about extraneous solutions? You should have some time in algebra, particularly algebra 2. And so you get extraneous solutions like a couple of different ways here. But one of those ways is whenever you square things. So we'll go back to algebra. Let's do this here. This would be probably an easy example to understand here. So 5 is equal to 5. Everybody agreed? Yes, you should agree. If you were to square both sides, you get yourself 25 on one side and 25 on the other. That's easy. Okay, so notice the 25s are equal to each other, and it points back to know, hey, those two things are equal to each other in the beginning of it all. Good. Here's where the problem comes in. Are these two equal to each other? No, negative 5 and positive 5 are not equal to each other, but here's our little problem, is that when you square something, you could get things that are equal to each other, right? But originally, they were not equal to each other. So that's our little problem. So whenever you square two sides of an equation, it could be that originally they were not equal to each other. That's our problem. All right, so let's begin our problem with that in mind. So first things first, we are in radian measurement. So whenever we get an answers, we're going to place them in radian form. All right, second is whenever you square something, you want to have one trig function all by itself before you start squaring, or else it gets even more complicated, and you don't want that. So before we start squaring this, I want to get one trig function by itself. All right, the other question is, when do we do this in the first place? When do you want to square an equation? Is when you have two different trig functions, there's no way to put them together. So sine and cosine are perfect for that. If you have sine and cosine inside a single equation, there's no way to factor these out. There's no way to solve them. There's no way to substitute like we did for cosecant earlier. So we're kind of stuck because there's no way to solve each of those and subtract them to get a square root of 2. It doesn't happen. So here it is. And I mostly want to stick with plus signs. So if I'm going to solve, I might as well have some plus signs to bear. So I'm going to move this over. So notice I have now the sine x by itself. That's cool. One trig function by itself. Perfect. Let's start squaring. So we're going to square both sides. Again, there's I think 2 or 3 ways to do these kind of problems, but this is by far the easiest way to do it. And so sine x squared becomes sine squared x. This one you do have to FOIL out. So this is somewhere on the side, maybe over here. I'm going to do it on the side over here. I have to FOIL this out right here. Root 2 plus cosine x, root 2 plus cosine x. And if you know the shortcut of FOILing it out, go for it. If you don't, let's follow me here. So square root of 2 times square root of 2 is a 2. Square root of 2 times cosine gets you root 2 cosine x. Another one gets you another one, so root 2 cosine x. And then at the end, cosine x times cosine x gives you cosine squared x. Okay, putting it together, particularly these little 2 terms right over here, gets you a 2 on the outside, gets you 2 radical 2 cosine x in the middle, and then gets you cosine squared x over here. Alright, and then it's some students, what they usually like to do, or they'll bring this cosine back over here thinking they're going to do a Pythagorean theorem with cosine squared plus cosine, sine squared plus cosine squared equals 1, and that does not happen, because remember, if you move it to the left side, it's going to be a minus cosine squared, so you can't use that. But notice what you have here is you have a sine squared, here you have a cosine, and then here you have a cosine. So using Pythagorean theorem, my question to you is, do you want to switch this to 1 minus cosine squared, or do you want to switch this one to 1 minus sine squared? Which way do you want to go? And all depends on this little guy right here. So notice you have a linear form, we call it, a linear form with just a cosine x. So in that case, what you want to do is you want to convert everything into cosine. So one trig function. So this becomes 1 minus cosine squared x right here. Boom. Okay, so now notice that we have everything just in terms of the trig function of cosine. That is a big deal. We've got rid of sine x. That's essentially what we did. We got rid of sine x finally. Okay, now we got ourselves another problem. Because notice we have a cosine squared, and then we also have cosine. So in your mind, whenever you see something squared, and then you see its own term in a linear fashion, you're thinking about factoring. I got to factor this down. How do I factor this down? And so we're going to move everything over, set it equal to 0, and see how we can factor this. Let me drop the parenthesis here. That's what I want to do here. I'm going to drop the parenthesis. And I'm going to move everything over to the left side, set it equal to 0. So minus cosine squared x gets me, and then you could do it all in one step if you like. You can subtract 2 if you like. I'm going to kind of do it just one single step so we can see it. So there's that. I'm still left with this stuff on the right hand side. Alright, let's see what else. I'm going to move the 2 over. That would make a -1. And I'm running out of space here, so let me write it on the next slide here. So 1 minus 2 makes a -1. I still have 2 cosine squared x, and on the other side I have this little 2 radical 2 cosine x. So I'm going to move this over to over here. Oof, okay, and you thought algebra 2 was kind of fun solving equations. Look at this. Okay, so a few things here from algebra 2 that we learned is I want to write this in decreasing order of my exponents. I want to go with the highest first, then the linear form, and then my constant. Okay, next thing. From Algebra 2, we know that if we have a negative term in front, we don't like negative terms before we start factoring. So we're going to multiply both sides by -1. Alright, and when we do that, this becomes 2 cosine x squared plus 2 radical 2 cosine x plus 1. So voila, now I'm ready for factoring here. Alright, in these cases, this is where we get to the fun stuff here. So unless it factors easily, and you kind of think of factoring, you can always use quadratic formula if you like. In fact, let's use quadratic formula here, because I'm not sure I really want to factor down a 2 root 2. That's not going to happen, not with factoring. So let's go for it here. So factoring it is cosine x is equal to -b plus or minus square root of, and this is kind of careful here when you do this one here. It's going to be b squared, right? So it's going to be this times itself. So this is going to be 2 times 2, which is 4, and a radical 2 times radical 2, which is 2, which is 8. So this is 8 minus 4 times a times c all over 2 times a. All right, let's see where this takes us. We have 2 radical 2. Let's see, this is going to be, oh, look at this, interesting. It's going to be 4 times 2 is 8, 8 times 1 is 8, and 8 minus 8 in there is just going to be a 0. That just disappeared. 2 times 2 is 4. So I have myself with a -2 radical 2 over 4. These guys are gone. That becomes a 1, or -1 technically. That becomes a 2. And now I'm left with negative radical 2 over 2. So along my graph here, tell me in radian form, when does cosine give me a negative radical 2 over 2? And that happens at 3 pi over 4, and that happens at 5 pi over 4. That's perfect. So I have answers of x equal to 3 pi over 4 or 5 pi over 4, and that is why we have the or statement here. Is because, remember, what did we just do in the early stages of this? We squared both sides of our equation. So it could be that one of those don't work. It could be that both of those don't work. It could be that both of them do work. So here's what we've got to do. We've got to plug this back into our original equation and see if they will work. So back to original equation, I'm going to plug in our check. So let's see, our original equation was this. It was sine, what is it, sine x minus cosine x equal to radical 2, right? So let's plug in, let's check. In fact, let's go check 3 pi over 4. Does that check out? So sine of 3 pi over 4 minus cosine of 3 pi over 4. Does that, with a little question mark, does that give you radical 2? So go ahead, you check it, look at the unit circle, see if it's going to check out. So sine of square 3 pi radical 4, long answer, that becomes a radical 2 over 2. Cosine, that becomes a negative radical 2 over 2. Still a question mark. I'm not sure if that is correct or not. But notice what happens here. That becomes a plus sign. Keep on going. That means we get 2 of these guys. The 2's cancel. And yes, that does check out. So 3 pi over 4 does check out. Okay, let's check out the other one here. Let's check out 5 pi over 4. Let's see if that does it. All right. Sine of 5 pi over 4 minus cosine of 5 pi over 4, question mark, gives me radical 2, yes or no? Let's check it out. So 5 pi, that's in quadrant 3. This is a negative radical 2 over 2 minus cosine is negative radical 2 over 2, and that's a no-go. That does not work out. Okay, so final answer here. And let me just check, that's in terms of x, is that right? We have x, yeah, should have been x right over here. Solve everything in terms of x. So x equals, so there it is, only one answer here that checks out, back to the original equation, which is 3 pi over 4. Alright, example 6, same thing happens here. So in order to solve this, somehow eventually we're going to have to square both sides. Notice you have a sine and then you have a cosine. Also, the other piece here is, notice that you have a sine of theta divided by 2. So there's the other sort of hang up that happens over here that we have to sort of think through as we do this. So let's go for it. Let's see what happens here. Let's see how we do this. So solve sine, I got a sine, I got a cosine, there's no way to convert. If it was a double angle formula for sine, I might be able to work it out with something, but still stuck. Alright, I'm in radian mode. That's cool. And let's go for it. Let's move this cosine over to that. That's cool. And then let's actually use an identity. So back to your identity list, because there's no way I'm going to start working with half angles here. Do you remember the half angle formula for sine? I believe is this right here. So we're going to plug that right in. This is plus or minus, we don't know, but we'll be able to check answers later on. We're going to get to this part right here. Cool. At least they got it. Hey, now notice, just by doing that, now I have everything is in terms of cosine. That is great. That's what I want. Everything is in terms of cosine, except now I have this little square root to deal with. So how about if I deal with it by squaring? So if by squaring that side, it just becomes 1 minus cosine theta over 2. And this side's going to be a little bit of a thing to do here. So off to the side again. If you know how to do it the shortcut method, go for it with the shortcut method. I'm going to do FOIL here. So 1 times 1 is 1. 1 times negative cosine is a negative cosine. And then negative cosine times 1 is another negative cosine. And then negative cosine times another negative cosine makes a positive cosine squared theta. Okay, so let's bring that down. This is going to be 1 minus 2 cosine theta plus cosine squared theta. Okay. So I do have that little denominator of 2. So what I'm going to do, just so we don't have fractions anywhere here, I'm going to multiply this side by 2. I'm going to multiply this side by 2. And I get that cancels. So this is not clearing the denominator. We don't do that. We only do clearing denominator with trig functions. This is just normal algebra, multiplying by 2 to get rid of fractions here. So 2 times 1, 2 times a negative 2, and then 2 times the end over here, so it becomes 2 cosine squared theta. Okay. Do you guys see a cosine theta and also a cosine squared theta? Yes, we do. Okay, here's what we're going to have to do. I have to move everything over, set equal to 0, and factor. So I see a lot more things on the right hand side. So what I'm going to do, I'm going to move everything over to the right hand side. A lot easier to do it this way than just trying to move 3 pieces here. So I'm going to move it all at once. I subtracted 1 from both sides. I added cosine to both sides. I get myself a 0 on this side. 2 minus 1 is 1. Negative 4 plus 1 makes a negative 3 cosine theta. And this becomes 2 cosine squared theta. Okay, are we good there? Alright, we have to, first of all, we have to line them up. Let's see, I don't like the 0 on the left side. I want to switch them over. Let me switch them over to the right side. That's what at least I would like to do. So it's 1 minus 3 cosine theta plus 2 cosine squared theta is equal to 0. Okay, and then we also know that we need to go from highest degree to lowest degree, or highest exponent to lowest exponent. So let's do this. So 2 cosine squared theta, that's going to be first. That's going to be a second one, and that will be a third one right here. Okay, so you have 2 choices here. If you want to do guess and check on this one, go for it. If you want to do quadratic formula, go for it. They're going to both work the same. The quadratic formula, guess and check method is going to work the same. I'm going to use the guess and check method because I think this might be pretty easy for guess and check. So here it is. I need 2 numbers multiplied to give me a 2 cosine squared theta. That can only happen one way. It happens this times this. Alright, the reason why I think it's going to work really quick here with the guess and check method, because there's only one way, or actually no, there's only 2 ways to get a positive 1. It's either negative 1 times negative 1, or positive 1 times positive 1. But I kind of already know which direction I want to go. So notice I need a negative 3 cosine in the middle. So that means it has to be that I got a minus 1 here, minus 1 here. So notice if I check the outside terms, that'll be a minus 2 cosine theta and a minus cosine theta. So do those two add up to a negative 3 cosine theta? Absolutely. So let's do that. Let's set this one equal to 0. I could say or set this one equal to 0. And let's see if any of them give us answers that we like. So I'm going to add 1, divide by 2. So I'm looking, when does cosine give me a 1/2? And cosine gives me a 1/2 at what, 60 degrees? And 300 degrees. So that's 60 degrees here, 300 degrees there. Okay, let's move the 1 over. And so when does cosine theta give me a 1? Cosine theta gives me a 1 right at 0. Okay, so hold on before I get ahead of myself here. I best check here. Am I in degree mode or radian mode? Oh, I'm in radian mode. So, I better convert all this to radians. 300 degrees in radians is, well, this one's easy. This one is just going to be 0. Alright, that is going to be 5 pi over 3. Okay, so guess what we have to do? We have to check each of those back to the original equation to see if they all will work out. Alright, so let's check. Here we go. Let's check the 60 degrees, or pi over 3. So back to the original equation here. So let's do this here. Check. Pi over 3. It's going to be sine of pi over 3 divided by 2 plus cosine of pi over 3. And the question is, does that give me a 1? So real quick here, I guess we got to do this here. Sine, if you take pi over 3 divided by 2, you're going to get pi over 6. That's going to stay as pi over 3. Question, does that give me a 1? Let's see. So sine of pi over 6. Sine of pi over 6, that is 30 degrees. That's 1/2. Cosine of pi over 3, that's 1/2, and voila. I should put a little put these little. So this is going to be, that's true. So pi over 3 works out. Okay, next. Let's check. Let's see if we can do it right over here. What else did we get? We got 5 pi over 3. Let's check that. So sine of 5 pi over 3 divided by 2, adding cosine of 5 pi over 3, question mark, 1. Does that give me a 1? Yes or no? And let's simplify that just a little bit here. So this is going to be 5 pi over 6 plus cosine of 5 pi over 3. And I'm going to go back to the textbook as well. Look at my unit circle. Yeah. See what I have here. So 5 pi over 6. Oh, sorry, 5 pi over 3. Yeah, sorry, 5 pi over 6. This is going to be negative radical 2 over 2. Sorry. My fault. This is going, so alright, this is going to be 1/2. And cosine of 5 pi, that gets me a 1/2. Hey, that's interesting. Okay. Question mark there? Question mark? Yes, but it does. 1 is equal to 1, so 5 pi over 3 works. That's cool. Okay, last one to check. That's going to be the 0 degrees. Should be the easiest. Here it is. 0 radians. Sorry, 0 degrees. 5 over 3 plus cosine of 0. Does that equal 1? So sine of 0, because 0 divided by 0. 0 divided by 2 is still 0. That gives me 0, that gets me a 1, and voila, of course, hold on, here it is. You got to put these little question marks down, but eventually that works. Okay, so for this one, got to think about it. I'm in theta, right? I'm in theta mode. Okay, theta is equal to all three work out and work out good. So that one, and that one, all three work great. Got them all. Alright, and the last one. There it is. Example 7 says find all the degree solutions in an interval from 0 to almost 360. If rounding is necessary, round to the nearest tenth of a degree. Use your graphing calculator then to verify each equation graphic. So you're going to solve it first, and then you're going to just kind of verify to make sure that is true. So let's go for it. So think about the methods that we've learned, methods 1, 2, and 3. Think about which way you want to employ them in order to solve it. What kind of piece is this here? So I look at this and I'm thinking to myself, you know that cotangent right there and that cosecant? I'm going to change it up to what I know, and I like to put everything in terms of sines and cosines. So cotangent is going to change into a cosine theta over sine theta. This guy's going to change into 1 over sine theta. And then I also have a 6 sine theta here. Just setting it up just a little nicer so it looks a little better. Alright, there's that, and that. Okay, so my question is this. Which method are we going to employ? Is it changing identities? Is it clearing the denominator? or is it squaring both sides? And I'm going to go with clearing the denominator. The only thing I'm going to do first is I'm going to put all this together underneath one piece. So it's going to be 13 cosine theta plus 11 over sine theta is equal to 6 sine theta. Alright, so let's go with it here. I'm going to clear my denominator of that, oh, wrong button. I'm going to clear my denominator of the sine theta on the bottom. I'm going to multiply by this. Okay, and then the other thing that we got to know is when we do that, remember we got to put something over here. We got to say sine theta does not equal 0. We're gonna say that never happens, and then we're gonna go from there. So I'm gonna cancel both of those out finally. So 13 cosine plus 11. I'm running out of room. So all yours there. Hopefully you're at the other end here. So 13 cosine theta plus 11. So 13 cosine theta plus 11 is equal to 6 sine squared theta. So we have this square term, and then I notice that I have my called the linear term that doesn't have an x squared next to it. It's cosine. But then on the other side I have sine, but I have a sine squared. So how about just changing everything in terms of cosine? Okay, Pythagorean theorem, here we go. We're going to use this guy as our identity of choice. We're going to plug it right into that. So how about 13 cosine theta plus 11 is equal to 6, 1 minus cosine squared theta. And let's keep on going. I'm going to distribute the 6 to each of these guys. I am going to let's move things over. So I see a cosine term. I see a cosine square term. Again, factoring. Factoring or quadratic formula. Let's move this guy over here to the left side. Let's subtract 6. Let's do all that. So that's gone. That's gone. So on the left now I have 6 cosine squared theta plus 13 cosine theta plus 5 equals 0. Okay, here we go again. You could use quadratic formula. Perfectly fine. You can do guess and check. Perfectly fine. You can do either one of those to get what we need out of this. Alright, since I did guess and check last time, I guess this time I'll do quadratic formula. So let's go with it here. So I'm going to go with, let's see, cosine theta is equal to negative b plus or minus the square root of b squared. Ooh, this has got some big numbers here. B squared minus 4 times a times c all over 2 times a. Okay, got some big numbers here, but let's see if we can work it out. So just inside the square root here, I got 5 times 6 is 30. 30 times 4 is 120, so I have 169 minus 120, and if that's the case, hey, I got a 49 here. I know what 49 does. Let me write it a little bit higher here. So that was 169 minus 120 gave me 49. This is negative 13 plus or minus square root of 49 over 12. Let's keep on going. This is negative 13 plus or minus 7, because that's the square root of 49, over 12. So I have two different problems. I got negative 13 plus 7 divided by 12. I have a negative 13 minus 7 divided by 12. So let's go with each of those. So negative 13 plus 7 is a negative 6 over 12, and I got myself a negative 1/2. I'm going to go with this one, and this one is a let's see, negative 20 over 12, reducing that by what? By 4. That makes negative 5 over 3. That's cool. Okay. So let's think about this here. Where along the unit circle does cosine give you a negative 1/2? Again, got to think back. Am I in radian mode or degree mode? I am in degree mode. Okay. Cosine gets me a negative 1/2 at 120 degrees and at 240. That's when that happens. When does cosine along the unit circle give me negative 5/3? Never. It does not ever do that. Okay, so question I guess is this. Did we get any time that the sine theta was 0? We didn't. Cool. Did we square anything? No, we didn't square anything. So therefore I don't need to check my answers. The answers that I got are here. I don't have any extraneous answers. Alright, so with that, I'm going to just say yes, that is true. I got to answer 120 and 240. Okay, so now let's check it on our calculator, see if that's true. Or how do we check this in our calculator? So I'm going to get a calculator real quick here. So I'm going to go 240. I got to get 140 and 120 and 240 along this here. So I have to punch this into my calculator first. So let's go with it. Y equals. So I'm going to punch in. Let's see. My calculator has sine, cosine, and tangent. So let's kind of go back to where we were before. I'm going to go to here. I'm going to go to this one right here, because that gives me cosine and sine, 1 over sine. So maybe this one right here. This is the one I'm going to plug in. So I need to plug in a left-hand side in my calculator and a right-hand side in my calculator. So let me do that. Show taskbar. Let me just get to this. Okay, let's go with it here. So off to the side here, I'm going to punch in, let's see, 13 cosine of x divided by sine of x. Oh, that's cool. Plus 11 divided by sine of x. Okay, that's going to be my left side of the equation. We'll string it over the other side. My other side is just going to be 6 sine of x. Okay, so there it is. I'm just verifying this answer in terms of a calculator. That's all. So I should get 120 and 240. Okay, so I guess before I start graphing this, I guess I better go to mode. And I better be in degrees, because that's what I need to be in. That's the way I did my problem. If I was in radians, I'd switch to radians. So there's that. What's the other side? The other side is, let's go to window. And let's kind of make these so that we see what we got here. So it's a trig function. So I don't need to go very high or very low. I do have this 13 on the other side though. So I'm going to just try here. Let's see. So x minimum is going to be 0. X maximum is going to be 360. And I want to go by 45s. My little tick marks are going to be 45s. My y minimum is going to be 10, negative 10. Let me keep it for now. Let's just see what happens with that. Okay. If you guys got it, let me graph it here. Let's see what we got here. So first equation, go. It looks like this. Whoa. Okay. Second equation. Ooh, nice. I like that. Okay, so I'm going to try to figure out, when does it hit here and here? When do they cross each other? When are they equal to each other? That's what I want to know. Okay, so the way we get that is we go to something called calc. So CH6 on your calculator, and you might have to press the second or the third function in a calculator depending where it's at. So I'm going to press second function, calc. And I want to find out when they intersect. That's what I want to know. When do these guys intersect? So number 5, clicking on that, number 5. So it says first curve, and you get to move this around here with these little guys right here. So you got these little flashing little thingamajiggy right here. Yep, say that's my first curve. Click enter. Since we only plotted 2 equations anyways, this would be the second curve. So click, and then it says guess. So you just want to kind of get a little closer to that intersection point right over there. Closer to the intersection point and go. Let's go do 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 do. Does some fun stuff like that. Voila! Look at this. I have an intersection point of 120, which is what we got. And so then we just do the other side. So let's go with it again. Calc feature. So second function, calc. Whoa, not that. Yeah, I did that. Intersection. I want to know where they intersect. And this time I want to move kind of a little closer to that side. You could put it here if you like. Actually, let's do it here. First curve, yes. Second curve, yes. But then the guess has to be close to that little intersection point. So you want to go kind of drive it right over here. And again, just using your arrow keys. And click. And let it compute. Let it compute. Dun, 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 dun. 240. All right, there it is. And that's how we solve things in terms of a calculator. It's just that little intersect function that we use. All right, so that is it. That is it for 6.2. And we'll go on with 6.3 later on.